Here is the pre-calc homework section 4.2. You're finding all the rational and real zeros. So using the rational zero test and synthetic division, question number 1, what you want to do is do the PQ test. You want to take factors of the constant, which is 3. So plus or minus 1 plus or minus 3 over the leading coefficient plus or minus 1. So what you're going to do for this one, we're going to start off by using synthetic division. I always start with a 1. If you try 1, you're going to use a 1, a 3, -1, and -3. Bring down the 1. 1 times 1 is 1. Add, multiply, and you get your first 0. So 1 is your first 0. So if you were to break this into x minus 1, you have 1 degree less, x squared plus 4x plus 3. Then you can use the simply factoring this to find the other two zeros, x plus 3, x plus 1. So in factored form, that would be in factored form, but all the rational zeros would be 1, -3, and -1. For number 3, your possible zeros are 1 and 5 over 1. So I'm going to start with 1. I always start with 1. And I'm going to use 1, 5, -1, and -5 for your coefficients. Bring down the 1. 1 times 1 is 1. You're going to add, you get 6. Multiply, you get 6. Add, multiply, 0. So x minus 1 is your first 0, and then you have x squared plus 6x plus 5, and this is factorable. X plus 5 times x plus 1. So what are your rational zeros? 1, -5, and -1. Number 7. This one does not have integer coefficients. So what you want to do is multiply everything by 12. So if you multiply this by 12, this by 12, this by 12, this by 12, your new problem will read 1x cubed plus, that's a minus x squared minus 8x, and then plus 12. So your possible zeros are factors of 12 over factors of 1. So it's plus or minus 1. All the numbers that go into 12 are 1, 2, 3, 4, 6, and 12. All over 1, plus or minus 1. So let's start with the number 1. If we try 1, you're going to use 1, -1, -8, and 12. Let's try 1. Bring down the 1. 1 times 1 is 1. Add, multiply, and I already know this is not going to work. Let's try 2. We have 1, -1, -8, and 12. Bring down the 1. 2 times 1 is 2. Add, multiply, we get -6, and add, and you get your 0. So your first 0 is x minus 2. Well, it's actually 2, but in factored form it's x minus 2. And then down here you have x squared plus x minus 6. And you can finish factoring this by simply factoring it. You get x plus 3 and x minus 2. So your zeros are 2, which is twice, and you can factor this by squaring it, x minus 2 and then x plus 3. But your rational zeros are 2 and -3. Now for number 11, what you're going to want to do is get rid of these decimals and make this x cubed minus 19x and then plus 30. And I did that by multiplying everything by 10. Now, I'm going to tell you your first zero is gonna be 2. If you did 1, 1 doesn't work, so you have 1. Now there's a 0 here for x squared, negative 19 and 30, okay? You wanna make sure if there's a missing term, you insert a 0. So bring down the 1, 2, 2, 4, negative 15, negative 30, and 0. So you're going to have x minus 2, and then x squared plus 2x minus 15, and then this factors to be x plus 5, x minus 3, and your zeros are 2, negative 5, and positive 3. For 13 and 15, all you need to do is just factor these. So you need to find the 0, the first 0, and then break this up. So, using the possible rational zero test, your P and Q, it's plus or minus 1, plus or minus 2 over plus or minus 1, plus or minus 2. So we have plus or minus 1, plus or minus 2 over plus or minus 1, plus or minus 2. So we're going to start off with, let's do 1. Let's try 1. 2, negative 4, 1, negative 2. Bring down the 2. 2 times 1 is 2. Add, multiply, and you don't get a 0. Let's try 2. So we have 2, negative 4, 1, and negative 2. Bring down the 2. 2 times 2 is 4. Add, multiply, and add, and you get your first 0. So x minus 2 is your first factor, and then you have 2x squared plus 0x plus 1. So how you would try to factor this, 2x squared plus 1 equals 0, is you would subtract a 1 and divide by 2. You get x squared equals negative 1/2. But when you square root this, you see that this is negative, so these are not going to give you real solutions. So in factored form, this is factored for you, it's done. The next one, same thing. You are going to take first of all, your constant does not exist right now, so what you'd want to do is pull out x cubed, because we have x cubed common. X cubed, and you're left with x cubed plus 2x squared plus 3x plus 6. Now you have a constant. So your factors are 1, 2, 3, and 6 over 1. These are your possible zeros. So let's start with 1. Let's try 1. Does 1 work? If we put a 1 out here, you're going to use 1, 2, 3, and 6. My guess is it's not going to work because these are all positive numbers. When we do this, we're going to see that this is going to be an upper bound. Bring down the 1. 1 times 1 is 1. You get 3, 3, 6, 6, and you get 12 here. These are, when you have a positive number and these are all positive, that's an upper bound. So you're not going to try 2, 3, or 6. You're going to go the other way, like trying negative 1. Try negative 2. Let's try negative 1. 1, 2, 3, and 6. So bring down the 1. You get negative 1. Add, multiply, add, and you're not going to get. So again, we have all positive. This is not an upper bound because it's negative. So you're going to have negative 2 here, and you get 4. So you don't have anything yet. So try negative 2. Try negative 2. 1, 2, 3, and 6. Bring down the 1. You get negative 2. Add, multiply, add, and you got your first 0 right there. So you've got x plus 2 is your first factor. And besides x cubed, don't forget you had x cubed here. And then for your leftovers, you're going to have x squared plus 3. But when I try to factor this, you're going to get a negative under the radical. So take a look at that x squared plus 3. If you set this equal to 0, you'd have a -3 here when you take the square root. These are imaginary. So in factored form, this is your answer right here, x cubed times x plus 2 times x squared plus 3. That is factored completely. Your rational zeros or your real zeros would be 0 and -2 only. The last two, number 23. So we're going to use your possible zeros are plus or minus 1, plus or minus 2 over, plus or minus 1, plus or minus 2. So let's try 1. And I want all real. Real consists of rational and irrational. So we have 2, -5, 1, and 2. So let's bring down the 2. Multiply, you get 2. Add, multiply, add, multiply, and we have our first 0. So x minus 1, that's this factor, and then you have 2x squared minus 3x minus 2. So now we're going to use the quadratic formula, not complete the square because of this. This is a 2, and obviously that's going to give you a fraction when you divided everything by 2. So let's find these two zeros. We're going to do -b plus or minus the quadratic formula, b squared minus 4ac all over 2a. So we have 3 plus or minus 9 minus 4 times 2 times -2 all over 2 times 2, which is 4. So let's simplify this. You get, and this may have been factorable, by the way. You could have checked this out, but let's continue going. We have 3 plus or minus the square root. We've got 9. We're going to have 9 plus 16. And what is 9 plus 16? It's 25. So this was factorable because this is going to give you the square root of 25, which is 5. So 3 plus or minus 5 over 4. So what are these two answers? Well, 3 plus 5 is 8, and 8 over 4 is 2. And 3 minus 5 is -2. -2 over 4 is -1/2. So what are your zeros are going to be 1, 2, and -1/2. These are your zeros for this problem. Now, if you were asked to write this in factored form, these are your real, your rational zeros. To write this in factored form, it would be, I'm going to write it here to show you, it would be x minus 1 times x minus 2 times x plus 1/2. And that would be factored completely. And the last one, number 27, your possible zeros, we've got a long list, plus or minus 1, 2, 3, 4, 6, and 12. So we're going to start with, if we try 1, 1 doesn't work. Let's try 2. Let's try 2. We've got 1, 1, -19, 32, and -12. So bring down the 1, you get 2, add 6, -13, -26, 6, 12, 0. We have our first 0. So now we have x cubed. This is x cubed plus 3x squared minus 13x plus 6. Now what you can do here is you're gonna use 6 and 1 for you're not gonna use 12 anymore. So let's try 2 again and see if that works. 1, 3, because if 1 didn't work when we first tried it, it's not gonna work for this one either. So you can throw that out. So you have 6 here. Now bring down the 1, you get 2, add, multiply, add, and you get -6. It worked again. So you have x minus 2. 2 worked twice, so you're going to square that. And then what's left here is x squared plus 5x minus 3. Now, this is not factorable. So what you have to do is use the quadratic formula to try to find these other two, because they want all the real zeros. So you're going to do negative b plus or minus the square root of b squared minus 4ac all over 2a. So you have negative 5 plus or minus, we have 5 squared is 25, minus 4 times 1 times negative 3, all over 2. So you end up with 25 plus 12, which is 37. So these are two irrational zeros. So our answer for this is we have two 2's, and then we also have for this one negative 5 plus or minus the square root of 37 all over 2. So the 4 zeros for 27 would be 2 twice, and then negative 5 plus the square root of 37 over 2, and negative 5 minus the square root of 37 over 2. And that is done.